So this is the video of the 4-1 notes, which are properties of parallelograms. So first thing I want to talk to you all about is a quadrilateral. So a quadrilateral is a polygon with 4 sides, and a polygon is a closed object. Okay, it like has no openings. So some quadrilaterals though have special properties, and these special quadrilaterals are given their own names, and we're going to talk about several of those in this unit this week I should say. So parallelogram ABCD, okay. We can see that AB is parallel with CD. Y'all see that? And it's got the arrows on the sides that indicate that they're parallel, and that BC is also parallel with DA. Okay? So we've got opposite sides here that are parallel. So a parallelogram is a quadrilateral with 2 pairs of parallel sides. So these are your blanks in blue, y'all, so make sure you fill those in. Now, to write the name of a parallelogram, you're going to use the parallelogram symbol, okay? So here's a helpful hint. Opposite sides of a quadrilateral do not share a vertex, obviously. Opposite sides here. So notice we've got A and D for this side, and we've got B and C up there. So they don't share a vertex, right? So that's what it's talking about. The opposite angles do not share a side. So B and D are opposite angles. A and C are opposite angles. And obviously, we've got the side AB here and the side AD there, right? And that's what they're talking about. So these are some of our properties of parallelograms. So if a quadrilateral is a parallelogram, then its opposite sides are congruent. So what I'm going to do is put some tick marks on here. So we can see that AB is congruent with CD, and we can see that BC is congruent with AD. Okay, opposite sides are congruent in a parallelogram. The next one here is if a quadrilateral is a parallelogram, then the opposite angles are congruent. So again, hopefully you can see that angle A down here is congruent with angle C. And I'm going to do this with 2 arcs up here. Angle B, opposite angles again. Opposite means they're on opposite ends, right? Opposite, okay? So opposite angles are congruent. Then we also have that if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Now, consecutive means right next to, right? So that means if I were to add A plus B, then they would equal 180, right? If I was to add B plus C, those would equal 180. If I was to add C plus D, those would equal 180. And if I was to add A plus D, they would equal 180. Okay? So any pair of consecutive angles, if we add them together, they are going to be supplementary, which means they add up to will be 180. Then also, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So that means AC bisects BD. So that both of these. So that means AZ is congruent with ZC or CZ, and BZ is congruent with DZ. So here again, we've learned a whole bunch of new properties, and we're going to apply them now. So on this first example, it says in parallelogram CDEF, DE is 74 millimeters. So we're going to go ahead and label that. DE is 74 millimeters, right? And that means that we know that its opposite is 74 as well, right? So I'm going to go ahead and do that. Then it says DG is 31, so that's this length right here. That's part of our diagonal, right? Now, what we learned a minute ago, too, is that the diagonals bisect each other. So if DG is 31, then GF is also 31, isn't it? Then it says FCD is 42 degrees. FCD is this angle over here, and it's telling us that this angle is 42 degrees, which means its opposite angle is 42 degrees up here. And we can find the angle CFE by subtracting 42 from 180, okay? So, or EFC, however we want to say it. All right, so it says find CF, okay? So CF is the opposite side. So we know that CF is equal to DE, right? They are opposite sides. So CF is equal to 74 because the opposite side is equal to 74, right? All right, then it says find the measure of angle EFC. And EFC, let's see if we can find angle EFC. EFC is this angle right here, okay? So what you should notice is it's not the angle that we were given. We were given the angle FCD. But if we were to add the angle of FCD to the measure of angle EFC, then that should equal 180, okay? So we have FCD, so that's 42 is equal to the measure, plus the measure of angle EFC equals 180. So to get rid of EFC by itself, we're going to subtract 42 from 180. So the measure of angle EFC is going to be equal to 138 degrees. Okay? Which means if this angle right here is 138, then that angle up there also is 138, right? Because they're opposite angles. Then it says find DF. Well, when we talked about this one a minute ago, we saw that DG was 31 and GF was 31. So DF is going to be equal to DG plus GF, right? So didn't we have 31 plus 31 here? So that's going to be 62, and that's what DF is going to be equal to. And again, that's millimeters. Okay? All right, go ahead and do this. You try. Come back to me when you're done. So it says in parallelogram KLMN, LM is 28. So LM is 28 right there, inches, which means NK, or KN, is 28 inches. And then, so we're going to say KN is equal to, right, LM, right? So KN is equal to 28 inches, right? All right, then it says NML. So what else are we given? So we're given the LN is 26. So the whole length here, guys, this whole length is 26. So that means that would be 13, and that would be 13 because 26 divided by 2 is 13, right? Then it's also asking us about this angle NML. NML is that angle up there. And we're given the LKN. So this angle right here is 74 degrees, right? So that means that angle up there has to be 74, right? Let me write that in black so y'all can see it's 74 degrees up there, right? Because they're opposite angles, okay? So we know that the measure of angle NML is equal to the measure of angle LKN, right? LKN. And we were given that one. So the measure of angle NML is equal to 74 degrees. Then LO. So we had that, LN, which is the whole diagonal, was 13. So if we were trying to find that, then we would take 26 divided by 2, which is 13, right? The whole thing was 26, so half of it is the LO, L to O right there, okay? All right, example 2 says WXYZ is a parallelogram, find YZ. And then we're going to find the measure of angle Z as well. So again, we should know that opposite sides are congruent, right? This is a parallelogram. It tells us it's a parallelogram. So that means we can say that 6A plus 10 is equal to 8A minus 4. Now it's asking us for YZ. Well, the only way we can find YZ is to do this to solve for A first, right? Subtract 6A from both sides. That gives us 2A here. That's now gone. Add 4 to both sides. So that's going to be equal to 14. Divide both sides by 2, and A is equal to 7. So now to find YZ, we are going to have to put that 7 in there. So we're going to go 8 times 7 minus 4. So 8 times 7 is 56. 56 minus 4 is 52. So that was our answer for YZ. Okay. Then it's asking us for angle Z. So here we have two angles that are next to each other, right? These are consecutive angles. So that means when we add those two angles together, they should equal 180. So we're going to say the measure angle W plus the measure of angle Z is equal to 180, right? So this time we're going to have to add those together. So we're going to do our 18B minus 11 plus 9B plus 2 equals 180. Combine our like terms, so we're going to combine the 18 and the 9. That's going to give us 27B. And we add 2 to negative 11, we get minus 9. That equals 180. So now we're going to add 9 to both sides. So that's 27b is equal to 189. Divide both sides by 27. So b is equal to, what did I get here? 7. Okay? So now we got to plug that 7 back into the angle for z. So the measure of angle z is equal to 9 times 7, that's 63, plus 2, so that's equal to 65 degrees. And if we wanted to find this one, we could just subtract 65 from 180 and get 115, right? All right, let's see if you guys can do this. You try down here. Now, hopefully you remember that diagonals bisect each other, right? So what does that mean? That means that this segment is congruent with that one, and this segment is congruent with that one. So that's how you should set it up, okay? Come back to me when you're done. So we're going to find JG first. So JG is equal to what? JE, right? Or EJ. Doesn't matter which way you do it here. Okay, so that means I'm going to say W plus 8 is equal to 3W. I'm going to subtract this W from both sides. So that's going to give me 8 is equal to 2W. Divide both sides by 2. So this W is going to be equal to 4. Now it's asking us to find JG. So JG would be doing 4 plus 8, which is equal to 12. And a good way to check this would be to multiply 4 times 3, which would also be 12, because those have to be congruent, guys. So that's a really good way to check your answer. Now the next one asks us about FH, and that's the whole thing. But to solve it, remember again that we're going to have to set these parts that we have equal to each other, right? So this time we're going to say 4z minus 9 is equal to 2z, right? So I'm going to subtract, I'm going to subtract 4z from both sides. Okay, so that gives me negative 9 is equal to negative 2z. Divide both sides by negative 2. If we divide a negative times a negative, hopefully you remember you get a positive, right? So z is equal to 4.5. So now it's asking us for FH, right? So to find FH, we're going to need to, because we're going to add these two parts together. So to find FH, FH is going to be equal to FJ plus what? JH, right? Okay, so let's go ahead and do that. 4 times 4.5, that would be 18 minus 9, and that's going to be 9, okay? And then we've got, and that's going to be FJ, and then we're going to do for JH, 2 times 4.5, which is 9, right? Now, again, look up here. To find that length, what we want to do is add those two together, right? So we're going to go FJ plus JH. That's what's going to give us our FH, right? So that's going to be 9 plus 9, isn't it? That's 9 plus 9. So FH equals 18. Okay? All right, this next one says, use the following information. A gurney is a wheeled cot or stretcher used in hospitals. Many gurneys are made so that the base will fold up for easy storage in an ambulance. When partially folded, the base forms a parallelogram. In parallelogram STUV, VU, that's over here, is 91. And doesn't that mean ST is 91, y'all? Because they're opposite sides. Then it says UW is this right here, and it says it's 108.8, which means this right here is 108.8, right? Then it says STV, angle STV is 57. STV is that bottom left angle, guys. So STV is this angle right here. So it says that this angle is 57, which means this opposite angle up here is 57, right? And how would we find the angles that are consecutive to it? Do you guys remember how we would find this angle S right here? How would we find that? Wouldn't we do 180 minus 57? And that's going to give us 123, right? So that angle right there is 123, and this one down here is 123, okay? So now it says find SW. So SW, we've already got that. That was the 108 that we already wrote, 108.8. That's SW, right? TS, where is TS? Oh, we got that one already too, 91. TS is right there, right? I'll see TS right there, okay? Then US is the whole thing, okay? So when we do US, we're going to do 108. Wait. US, yeah, so this one is going to be 108.8 plus 108.8. So that's going to be 16, 8, 16, 17. So that's going to be 217.6. Okay? And then angle STU, Wait, did I put that in the wrong place, y'all? That STV. Oh, I did. STV. That's that angle right there, y'all. Made a mistake. Let's fix it. Okay, let's go back. So it's saying STV. So, no, TSV. TSV. Okay, so that was this angle, y'all. TSV was 57, which means that angle down there is 57. See, even teachers make mistakes. Okay, so then we are looking for, again, this would still be true here, right? Okay, because that is still a consecutive angle, which means this one down here would be 123. So that was my error, y'all, in not reading the problem correctly. So then STU would be this angle right here. So that one was 123. And then it asked us for TUV, which would be this angle right here. TUV would be that one right there. So that one's 57 degrees, okay? All right. So now, you try 3. So we're going to label this as it is here, and we're going to work through the problem. So it tells us that LP is 5, which means that down there is 5, and the whole length would be 10, right? OP, okay, let's talk about OP. OP is right here, right? And PM is right here. So if we set those equal to each other, OP is going to be equal to PM, right? All right, so let's go ahead and do the sides before we even go on to the rest of this. I just wanted to see what we had in the problem other than that, okay? So don't you know that this side is congruent to this side? So we're going to say that 12 is equal to y squared plus 3. Subtract 3 from both sides. That's 9 is equal to y squared. Remember, we take the square root of both sides. And we put a plus or minus in front of that. So this is going to be y is equal to plus or minus 3. Okay? Then we're going to do our other side here. So these are also congruent because they're opposite sides. Okay? So we're going to do 6x minus 7 equals 2x plus 9. Subtract 2x from both sides. It's going to give us 4x. We're going to add 7 to both sides. So that's going to give us 16, and we're going to divide both sides by 4. So x is equal to 4. Now we're going to plug this back in just a minute. I'm just solving for x, y, and z right now. Now OP and MP are equal to each other, right? So up here, we can say that 4z is equal to 5z minus 3. So we subtract 4z from both sides. Actually, let's just do it this way. Let's subtract 5z from both sides. So we get a negative z is equal to a negative 3. If we multiply or divide both sides by negative 1, it means that z is equal to 3. Okay? So now we have our x, our y, and our z. Okay? So it asks us to solve for that first. Now let's talk about our LM. So LM has an x in it, right? So we're going to go LM here is equal to 6 times 4 minus 7. That's 24 minus 7, which would be, so that's LM is 24 minus 7. That's going to be 24 minus 8 would be 16, so 17, okay? And if LM is 17, then that means what else is 17? ON, right? So this is also equal to ON because they are opposite sides and they are congruent, okay? Then let's go ahead and put our Y in. So if we do, well, we don't have to do that because it didn't ask us about that. Then it asks us about PN. Okay. So we've got PN already labeled, right? So PN is equal to 5. It's right there, PN, see it? And then LN is the whole thing. So LN would be 5 plus 5, which is equal to 10, because that's the whole diagonal, y'all. Then we've got OP, and what we need to do for OP is equal to 4 times Z, which is 3, so that's going to be 12, which also means that PM should be 12 is right as well, right? So 5 times 3 is 15, minus 3 is also 12. And then OM is the whole thing, so OM is equal to OP plus PM, which is 12 plus 12. So OM is equal to 24. Okay? All right, so this last you try is angles, okay? So this is a little harder because we're going to have to figure out how to relate these to each other with variables. So notice the only ones that have similar variables are these right here, angle B and angle D. Now they're opposite angles, so we can set them equal to each other, right? So we know that this angle is congruent with this angle, okay? So we can say 2x plus 3 is equal to x plus y, right? So now what I'm going to do is I'm going to subtract x from both sides. So it's going to give me x plus 3 is equal to y, okay? So now that I know what y is, I can put it up here, can't I? So that's what I'm going to do, because now hopefully you know that this angle plus this angle is equal to 180, right? So I'm going to say 2x plus 3 plus my x plus 3, that should equal 180 degrees, right? So 2x plus x is 3x. 3 plus 3 is 6. That equals 180. Subtract 6 from both sides. So that's 3x equals 174. Whoops. 174. So I divided both sides by 3, and I got x equals 58. Okay, so now when we look up here, we know that we could say that 2 times 58, now it's not supposed to be degrees, by the way, y'all, it's supposed to just be an x, okay? So, so for this, if we find the measure of angle B, we're going to go 2 times 58, come on, pen, 2 times 58 plus 3. Well, 2 times 58 is 116 plus 3, so that's going to be 119 degrees, okay? So if this is 119 degrees, then we know the angle next to it, y, is going to be 180 minus 119 degrees, and that's 61 degrees, right? So if y is 61, we also know that z's got to be 61, right? Because they're opposite angles, okay? And so now let's go ahead and see if we can figure out, so y, right here, y'all, y is going to be what? 61. So y is equal to 61, and z is equal to 61, okay? So we also know what angles A is 61 degrees, B is 119, C is 61, and which means D is also what? 119, because it's an opposite angle. Y'all see that? Okay.